Okay, I would consider this to be a pretty difficult problem. Looking at it, if you certainly even if you're given a head, you might have a tough time with it. Um, one thing to look at is to rewrite the one. So let's take a look at this. So sine to the fifth power of theta plus cosine to the seventh power of theta, and one could be written as sine squared theta plus cosine squared theta. I'm going to collect the sines on one side and the cosines on the other. So you're going to get sine to the fifth power theta minus sine squared theta is equal to cosine squared theta minus cosine to the seventh of theta. I would factor each side. Sine squared comes out. And what are you left off with? Sine cubed theta minus 1. On the right side, I'm going to factor out a cosine squared theta. And you get 1 minus cosine to the fifth power. All right, looking at the sides, it's certainly, some people say it's a dead end at this point. But one thing I notice about this over here is that, certainly these factors here are always going to be non-negative. Right, they're always non-negative. So I'm going to just simply say, greater than or equal to 0 for those. And looking at these ones over here, they look like they're, sort of like in a different order. So I want to, kind of write that down, that the sine cubed of theta, well, that's a bounded function between plus or minus 1. I can't exceed that. And then if you took 1 from that, what do I know about that? It's always going to be less than or equal to 0. So what do I know about this entire side over here? I know this entire side, whatever it is, has to be less than or equal to 0. All right, let's put the other side down. Erase this out. Well, again, I'm looking at that cosine squared. It's always non-negative. And then I look at the 1 minus cosine to the fifth. Let's write that down. Again, it's bounded. All right, so looking at that, that thing is always going to be greater than or equal to 0. So this side over here is greater than or equal to 0, the entire side. The only way for this equation to have a solution is if these things are simultaneously 0. In other words, if the left-hand side is 0 at the same time the right-hand side is 0. Well, let's take a look at that. And just looking, I'm just going to look in the first quadrant. And actually, not the first quadrant, but the first a cycle, which is between 0 and 360. And let's write down the degree measures for this. And we're looking at the sine function. So this thing over here, the sine function, right, I'm looking at the left-hand side, would become 0, well, certainly at 0, and then at pi, let me just pick degrees, okay? So 0 degrees, and 180 degrees, and 360 degrees. I'm seeing that. And it becomes 0 somewhere else. It becomes 0 when this guy becomes 0, which means when the sine function takes on the value 1, and that would be at pi over 2, or 90 degrees, all right? I'll put that down, 90 degrees, all right? That's done. Let's go to the other side, and I'm looking, when does a cosine function become 0? Again, this was the right side. Now we're going to look at the left side. Let's put the cosine curve down. Looks like this over here. And what would that be? It certainly, I know it becomes 0 there, and that's the first factor. The second factor becomes 1 here. Well, let's write this down. 0 degrees, 90 degrees, 270, and 360. All right? Again, this is where things are starting to repeat themselves. So let's take a look at it and talk about where they overlap. Certainly at 0, they agree there. They agree there. And the 360, but that's sort of like a repetition. So let's write this down, all solutions down. So I'm going to write down theta 2 pi k. That accounts for this. And theta equals pi over 2 plus 2 pi. Okay. All right, let's look at the k, make sure we did okay. And let's look for our answers over here. I'm looking for this one over here. And let's see. I see that there. And let's see if we see this one over here. Yeah. I also want to look at the picture and emphasize what the picture of. It's a picture of this curve here. That's the one in blue. And the line y equals 1. And what am I seeing? I'm seeing points. This is the 0 degrees. That's a 360 degrees. And it's got a cycle length of 360 degrees. We put ready to measure down. What's this thing over here? It's actually 90 degrees. And this one over here is going to be 90 plus 360, 450 degrees. And again, you can blow that thing up. Whoops, sorry about that, 450. You can blow it up and actually see the pattern repeated over and over again. Thank you.